Thanks so much for coming out or clicking a link and coming out to this conference. My name is Wes Bos. As I said, I'm from Canada, from a city called Hamilton, which isn't too far from about half of the other people. We probably should have just got all together in a room and all done our talks together. These slides today have a lot of code on them, and I'm going to tweet out a link to them. So if you ever want to come back and reference them or try any of the code yourself, you can grab them right from the actual slides. So I make courses. I have a course on ES6. I have a course on React. I have a course on Node, and I just released one on CSS Grid. All kinds of stuff. If you're interested, you can check those out. There's also, I believe, a coupon in the swag tab of this conference. So make sure you take advantage of that. I also have a podcast called Syntax, and we talk about tasty treats for web developers, which is essentially just like little nuggets of different topics that you can take away from and get up to speed. So JavaScript is always evolving. It's sort of this nonstop moving language, and we've had ES6, we know that, and then we had ES7, which is called ES 2016. We have ES8, and the language is just constantly evolving. We've got stuff like we've got new DOM APIs, and with this talk, what I want to do is I'm going to focus on parts of the actual core JavaScript language, which is promises and async await, and then also some new DOM APIs, some new stuff that's coming to the actual browser that you're going to be able to use in your actual applications. So if you're ready, I think we should get going. First one is I'm just going to do a quick baby review of promises, not because promises are new to the language, but in order for us to understand how async await works, we're going to do a quick review of how promises work. So promises are sort of like an IOU for something that's going to happen at some point in the future. So that could be an AJAX call returning some data. That could be accessing a user's webcam. That could be resizing an actual image. All of the things that I just said, all of those things take time. And with promises, we simply sort of kick off the process and move along with our lives. We're not going to wait and freeze up our entire application while we wait to resize an image, or while we wait to see if the user is going to give us access to our webcam, because there's a lot more that could be going on in our app while we're waiting for that data to come back. So the answer is, I got the answers. The question is, why do we do it this way? And that's because JavaScript, in all of its, whether you love it or hate it, it waits for no one. And what I mean by that is almost absolutely everything in JavaScript is asynchronous, meaning that if you have any sort of process that is going to take time, it likely will kick it off and move on to the next line of code and keep running through your actual application, rather than freezing things up or waiting for that thing to be done. So let's relate this to real life. You want to do a couple things. You want to make some coffee. You want to drink some coffee. You want to cook some breakfast. You want to eat some breakfast. Do you need to finish making the coffee before you can start breakfast? And I realize this is a terrible example because some people told me, well, actually, in the morning, I need to just have my coffee first, and then I can start doing other things. So that would make you a very synchronous morning person. But it wouldn't make sense to do that. It wouldn't make sense to wait until coffee is made and consumed before we can actually start cooking breakfast, right? So we want to start one thing and then come back to it once it's finished and deal with the result accordingly. In my example, we want to kick off the coffee, and then when the coffee is ready, we'll come back to it and we'll start to drink it and enjoy it. And that's all you do with coffee. So here is some actual pseudocode how it might work. We might first kick off the making coffee on the first line, then we'll kick off the making of the breakfast on the second line, and then we'll sort of listen for these things to be finished with a .then. This is how promises work. You have a .then on the end, and when the coffee is finished, then we have it and we can drink it. Or when the breakfast is ready, we're going to have eggs and bacon. We can go ahead and eat those. You can also, with promises, you can wrap it in this promise.all, which sort of makes it like a mega promise that will only, the word that we're looking for in promises is called resolving. That means when the finished data is coming back. And we can wrap it and we can wait for both the coffee and the breakfast to be finished before we move along with the next, which is we want to sit down for breakfast and eat those two things. So most new browser APIs that are coming to the browser are based either on promises or observables, and we'll talk about observables in a bit. So we've got fetch in the browser, and fetch is sort of like a jQuery's $.get JSON that will go off and fetch your data. It looks a little bit something like this. It's a double promise, so you have to first fetch the data, and then you have to convert it to whatever sort of data type you're expecting, whether that's text or JSON or anything else. And then finally, we can go ahead and use that data, like maybe pet the dogs. There's a library out there called Axios, which will allow us to do this in one fell swoop, which is really nice. It's got a lot of really nice features. So if you're actually looking to do Ajax in JavaScript, I definitely recommend checking out Axios. There's many, many more. The payment request API, the get user media, web animation API. I'm going to be talking about a couple of these. These are all based on promises. And it's great because you can also make your own functions that return a promise. So here's something we can all understand. We make a function called sleep. And what we do from that function is we immediately return a promise. And then inside of that promise, you can either resolve, which means that in this case, after maybe if you say sleep 1 second, it's going to resolve itself after 1 second. That means the promise is successfully come back. Or you could reject, meaning that maybe authentication error, syntax error, something that you want to sort of abort everything. In that case, you would reject the promise, and you can catch the error at a later point in time. So that's how you create your own promise. And it would work a little bit something like this, where you call off your initial promise function, sleep, and then you can chain these .then onto them. And as long as you return a promise from each of the thens, you can subsequently chain them as long as you could possibly want. So that's great because it solves this problem we've had in JavaScript, which is called Christmas tree code or callback hell. And that's a spot where we probably have all been in and really regretted it. And we end up with code that looks like a little bit something like this, where we wait for one thing to be done until we do the next, and then we eat our breakfast, then we drink our coffee, and then we clean up. This is very sequential where, as we talked about earlier, it's likely that we could kick off many of these processes at the exact same time. So with here's another example where if we were trying to animate something, we wanted to move to 50-50, and when that's done, I want to move to 20-100, and when that's done, I want to move to 100-20. You get the point, right? Like we just want to animate sequentially. In promises, you would just move to, and then you can chain all of these thens, and that's going to sequentially allow you to sort of queue up these different animations on the screen. So we get it. Promises are great, but they still are kind of callbacky. Like the .then is still really a callback. It gets us away from the Christmas tree-ness, but we still have that one final callback where anything that needs to come after that final then always needs to go inside of the final then, and it can't just go below the code like you would want to read it top to bottom. So this is where async await comes in, and the reason why I talked about promises first is because async await is still based on promises, but it's sort of a new syntax in the language that allows us to write code like we never have been able to before because it's new syntax to the language. This is not a library or any sort of new function that someone has built. This is brand new syntax that we have in the language. So we remember this example where we were in callback hell and then we moved to the promised land, as I like to call it. But we can make it one step further. We can switch this top promised land code over to what's called async await. And the way that it works here is first what you do is you mark your function as async. And then inside of that function, you can use this new keyword that's called await. And what awaiting will do is it will sort of pause that function from running before it moves on to the next line of code. It's not going to block anything else that's going on in the browser at the same time. That means like if you have some queues running in the background or you have somebody clicking a button on somewhere else in your application, it's not going to freeze up your interface or stop that from actually running. It's just going to sort of pause that one function from running before it resolves and moves on to the next line. So let's break it down into how it works. We talked about how JavaScript is asynchronous and non-blocking, but the problem is that it's hard to read and write asynchronous code because you either have callbacks or you have these thens, but really that's why we have async await. So this is what something like PHP would look like if you're not using any threads or anything special. Just open up a PHP file and start to use it, where you would fetch the Wes Bos from GitHub, and then when that comes back, you would fetch off Scott from GitHub, and then when that comes back, right underneath it, you can start to use that data. It goes top to bottom, and this is the first programming language that I ever learned, was that this is how it worked, and it was great because you could read it sequentially. With JavaScript, it works a little different, where you can kick off both of these requests one after another. We can wrap them in a promise.all that says, wait until both of these come back. If one takes 5 seconds and one takes half a second, it's going to wait the full 5 seconds. And then when they're all back, we have a .then, which will then give us both pieces of data, which we can then go ahead and use. So that's got me kind of feeling like it's okay. Like, the PHP is obviously much better to read. The JavaScript is more performant, and I'm really not really happy with either of them. So with async await, we sort of get the synchronous looking code without the actual waiting on the data to be returned before we can run any other code that goes along. So let's see how it works. First thing you need to do is mark your function as async. So here's an example that I've got here is the top code is our regular promise that we wrote earlier, where you pass in an amount, and that's going to either wait that amount of times and resolve, or it's going to reject, because in this case, it's too fast. We don't allow sleeping for anything under 300 milliseconds. This talk is sponsored by LaCroix. And next up, what we want is to mark our function as async, and then inside of it, that's where we're going to be able to doing our await. So you mark your function as async. That opens up this new world and tells the browser that you might want to pause this function inside of it. So what we do is we wait inside your async function. So we have a function called go, and inside of that, we either just wait for the sleep function to be over, or if you care about the result of that promise-based function, in this case, maybe you want to hear the data that comes back from an API, or a successful result from our sleep function, then you can actually capture that in a variable, and that variable will only be populated once the sleep function resolves itself. And then you can just use it the exact line underneath it, which is great. There's no callbacks, there's no thens, there's no weirdness going on here. We simply just wait for it and use it on the next line. So it's really the best of both worlds, as far as I'm concerned. It's really changed the way that I've been coding all of my applications. So let's look at another example that we have here. So in this case, we are first, this is the sort of the slow version that I showed you earlier with the PHP, where we await for Wes to come back, and when that comes back, we can wait for Scott to come back, and then when that comes back, we have both pieces of data, and we can go ahead and use them. So that's good, but it doesn't make sense to wait for things that aren't related. I can see, like, maybe you wanted to fetch the weather, and then when the weather comes back, you want to fetch some photos based on the weather. But in this case, they're totally unrelated. One does not need to wait on the other, so they should fire off at the exact same time, right? So we can use promises and async await for that. So in this case, rather than awaiting in front of the axios.get, we're going to immediately return the promise into two variables, Wes promise and Scott promise. Then what we're going to do is we're going to stick that into a promise.all, which sort of, again, it makes a mega promise. And we can await that mega promise. And when both pieces of data come back from the network, they will both resolve, which will then trip the mega promise.all to resolve. And then I immediately destructure those into a variable called Wes and a variable called Scott, and we can use them on the exact line right underneath it. Error handling is an entire, there's a couple different ways that we can do it. I don't have time for it in this specific talk, although I do have a talk up on YouTube that goes into the nitty gritty of the about 4 or 5 different ways to handle error handling. And it's not just the try catch that maybe you have seen online. There's a couple really nice ways that you can handle errors without having to give up the beautiful one level deep code that you've written. So we're done with async await, which is great. And let's see some new browser APIs that are coming or already here. The first one is intersection observer. And what does that mean? Well, intersection observer is going to help us know when an element is actually on screen. And what that means is that how do you know when an element is scrolled into view? So I made this stupid little video here where we've got a web page, which is yellow, and we've got some dogs on the web page, and then we got our viewport. Often we want to know when are those things either partially or all the way on the page, because if they are partially or all on the way page, we want to do something with it. So what are the possible use cases for that? Well, first one is that you can animate elements in on scroll, which means that as soon as a element peeps its head into view, then you can add a class of visible, and then you can use CSS to whoosh, bring that in or slide it out or anything like that. Play video when someone scrolls in. So if you have some sort of interactive website and you want to play the video, as soon as someone scrolls to that specific part, then it will start to show itself. Although all the browsers are now implementing this new thing where you cannot autoplay video unless the user has previously clicked many times to play video, and you sort of earn trust in Chrome. I forget what the name is. I can link it up later, but that's just something to know about that. You can lazy load images when scrolled in. You can record views for ads when they are beyond the fold. And I actually left this error by habit. I could use intersection observer to figure out that my text goes off my slide, and I could have resized the text, or use with sticky header. So let's look at some examples that we have here. So check these pigs out. These pigs are zooming. Oh, that wasn't a pig, but these pigs are zooming in and out of the web page as soon as they peep their head onto the screen. And then as soon as they go off the screen or partially off the screen, we can move them back out. So that's using intersection observer. And let's look at, I'll give you one more example, and then we'll look at how it actually works. So first, another example is with sticky header. So we have this thing coming to CSS called position sticky. And what you can do is, along with intersection observer, when that thing peeps its head onto the screen, you can apply a position sticky to it, and it'll sort of give you this like iOS looking sticky header where as you scroll through, that section will always stick to the top of it. And when I was building this talk, I thought like, oh, this is a perfect example for this talk. So I have all these auto-playing videos on my slides. However, I don't want to just have them all autoplay at once, because that would slow it down and that would use up a lot of bandwidth. But I also don't want to have to click the button to play it. So what I did is I used intersection observer, and I said, when the slide is 100% on screen, then check if there are any video elements inside of the slide and autoplay them. And then when the slide is off the screen, do the opposite, find any video elements and pause them. And that's really great, because I was just building this talk and I thought, oh, I need something like this exactly for my own talk. So let's look at the code. How does this actually work? First thing you want to do is set up a couple options. So you have your root, which is what is the element that is scrolling. In most cases, it's just like the window or the viewport of your browser. But if you have another, like a sidebar that is scrolling and you only want to figure out that, you can give it a root. You can have some offset margins if you have added margins to it in CSS. And then the important part here is the thing called thresholds. When do you want to be alerted to when the elements are either on or off screen? So what I said here is I want to be alerted when it's off the screen, like when it just scrolls off, which is 0, when it's halfway on, and when it's totally on. So those are the 3 points where I said, just let me know about those when they happen on each of the specific elements. Second is You want to create what's called an empty observer. So we say new intersection observer. You give it a callback and options. We haven't looked at the callback yet, but we have the options that we just did earlier. And then this is the callback. So essentially, when you're, in my example, is the pigs. When the pigs come on screen, the callback is going to get fired, and you're going to be passed two things: the entries. What are the elements that are being watched? In my case, it was some pig images, and then the actual observer itself, because you can turn it off if you would like. So in this case, what I'm doing is you get entries, and you have to loop over them because it could be multiple things that you're watching, and then you can check each entry to see if it's intersecting. And then you can also check what the ratio is. Remember earlier I checked for 0, half, and 1. In this case, I'm only concerned with when they're fully on the screen, and that is the intersection ratio of 1. If that's the case, we add a class. Otherwise, we remove the class, and then at that point, it's just a CSS issue, which we could slide them on in or slide them on out, depending on what we're looking at doing in this case. And then the final thing is that you simply just need to select your elements. In this case, I'm selecting anything with a class of box. And then for each of those boxes, you pass it to observer.observe. Remember, the observer is the thing that we made earlier. It was empty. We had a callback. We had some options, but it was not yet observing any elements. And in this case, you just pass it a whole bunch of images or divs or unordered lists or anything you could possibly want to watch. And then the browser will do the heavy lifting. And this is great because previously what you had to do is you would have to just on scroll, you would have to grab every single element, and then you'd have to check, is this thing on the page or not? And that was very expensive because you were always looping over and trying to figure out where these DOM elements were in the page. But it turns out that the browser knows pretty well what elements are on the page and what elements are not on the page because it has to print them to the page. So a native API for this is going to much improve performance. This is some of the data that you actually get when it fires a intersection event. So you get how big, how wide, the width and the height, where it is on the page for that actual element, the time since you started observing, which is kind of interesting, the actual target, and some other Booleans here, the ratio, the intersection Boolean, which we looked at in the last example. Next up is the payment request API. I'm going pretty fast here, so make sure you queue up some questions in the chat because I think I'll have some time to answer them. So next one is the payment request API. And I'm really excited about this, mostly because I sell stuff online. And if it's easier for people to give you their credit card information or their payment information in general, then you can make more money, right? So every single online store right now needs to reinvent the checkout form. Like, how many times have you written a checkout form in your life? It's probably more than once. So we're all just trying to do the exact same thing. We're trying to collect payment information, billing information, and just specific information that revolves around a transaction from the user, like an email address as well. So the payment request API is a standardized browser API that is used to collect billing and shipping information from your users. So rather than everybody implementing their own form and hoping that LastPass or Google autofill can figure it out, we're just going to standardize what this thing looks like, what the different kind of inputs are, and hopefully that you can only have to enter your billing information into your browser or your device once, and then you can just fill it in from there. So let's look at how that actually works. Take my money. It pops up a Chrome dialog here. You can select from your different credit cards, and you can supply billing addresses, and then you can go ahead and click pay. It'll ask you for your CVC, confirm, and then that will dump just an object full of data. And I'll talk about, there's a couple different ways that we could do this, but in this case, it just dumps an object full of the data on your lap, and then you can take that credit card information and billing information and then do with it what you were always doing. One more time. Pretty good. Wealthy Willie. Here's what it looks like on Android. So it will automatically pop up, ask you for some of your saved payment and contact information. You can select different kinds of delivery options because you might want to do FedEx or just like USPS or whatever it is. Here's another example where you click the button, it's going to pop it up. You can enter your CVC. And at that point, it's going to give some sort of information to the website, and then you, the website developer, can take that information in and go ahead and charge it. So, and here's what it looks like on Apple Pay. So Apple Pay is not currently using this. Obviously, Apple does the Apple thing, and they sort of like, I don't know if they forked the spec, but it's very similar, but it's not the exact same spec as Apple. So if you are using both, like most things on the internet, you have to sort of create a wrapper for it. And I'll talk about more about that in just a second. So the big question that, I don't know, maybe people are asking right now is, does the browser charge your card, and is it secure just giving a console.log of your credit card information? So my answer to that is, first, does the browser charge your card? No, it doesn't. At the very basic, it's a glorified autofill, meaning that rather than you having input type equals credit card and input type equals first name and last name and all these different inputs, you get rid of that, and then the browser will just dump all of these standard inputs on your lap, and then you have the person's name and the CVC and their credit card number and all that information. Then you take that information and you send it to your credit card processor, like Stripe or Braintree or whatever credit card processor you're using. So that's at the very, very basic. But there also is the ability, because like that still sucks. Like, even if it sucks to have to touch a credit card, because even if you're not touching credit cards on your server side, you still have to do the little get it from the user with JavaScript and then give the credit card number to Stripe. And then what Stripe does is Stripe gives you back a token, and then you take that token where you're like, whew, that's not a credit card, that's a token. I don't care if anything happens to it. You take that token to your server, you charge it, like this is the old ching thing. And then you charge that token, and that will in turn actually charge the user's credit card, which is great. However, what also happens in the case of Android Pay and Apple Pay is instead of Android Pay or Apple Pay giving your credit card number to the website, what it does is it gives them just a token. And then you take that Android Pay or Apple Pay token to some processor that supports Android Pay and Apple Pay. In this case, Stripe or Braintree all support it. Authorize.net, all the big ones. You take the token, you're like, hi, I have this token. I was told I could get some money. And then it will charge the token, and then you'll actually come back with the success data, and then you can give the user. And that's the best, because in that case, your credit card never goes anywhere. It never leaves your actual device. Because it's just tokens all the way down, and then there's no risk in anyone ever having your credit card, like especially some sketchy website owner that you're buying stuff off of, like me. I'm joking, I'm not sketchy at all. Is it secure? Yes, I just talked about that. Why are you asking that question? All right, let's talk about the next one, which is get user media. So get user media is actually not new at all. In 2011, which is like almost 7 years ago now, I did a blog post of how I was playing around with Get User Media. At the time, it was only available in Opera before Opera introduced the Chrome engine, and I did this like kind of fun thing where you put like glasses on top of your face and whatnot. So Get User Media is not new. And for those who don't know what it is, it's the ability to access your microphone and your webcam and theoretically any media device right away in the browser without any sort of like Flash or anything in between that. But like Safari doesn't give a shit. That was sort of the thing all along. However, in September 2017, when iOS 11 launched, we got two very important things. That was first, it plays in line, and second, Get User Media. So I think the reason why we didn't have Get User Media in Safari for so long was because when you get access to someone's webcam, you need to then take that webcam feed and put it into a video tag. And Safari didn't have the ability to put a video tag right in the page. It always kicked you off to their external player where you had to use the native controls in the native player. However, we got this new attribute called plays in line now. And what that will do is it will just play the actual video tag wherever it is in the page, like it would on desktop. And if you want to kick it off to a separate player, you're welcome to do that. So that sort of was like, okay, good, we have that. Now we can open up Get User Media and allow the user to access both of the cameras and the microphone off of somebody's actual phone. So here's a little example that I have just running on localhost. So the actual video of myself is a video tag. I'm piping it in off of my iPhone front-facing camera. And then when I take a picture, what you can do is you take an empty canvas element, and the empty canvas element just takes a dump of the current still from the video and puts it into a canvas element. And then at that point, you can either put glasses on it like I did, or save it directly to a JPEG with a data URI. And that's exactly what I'm doing on the bottom here. As I hit that photo button, I'm just like creating lots of pictures. I have a demo of that online somewhere if someone's interested in how that works. So that's really great. Initially, Get User Media was callback based. So you had two callbacks. You had a success callback when they give you access to the webcam. You have an error callback when you don't have access to it, when they say deny, and you have to tell them, hey, you denied it, so we can't show your actual camera. So in this case, this is all how it works, is you just select some sort of empty video tag. You create an async function called go. And I should note as well, with this async await stuff, there's no top-level await, meaning that you cannot just await anywhere you want. You have to always await inside of a function, and that function must always be marked as async. And then once you're inside of that, you just await navigator.mediadevices.getUserMedia. So that getUserMedia is going to return a promise. And when the promise successfully resolves, you're going to get the stream. And then you can just stick that stream into the previously selected video element, go ahead and play it like it was a regular video tag on any other page. Here's the example I told you earlier where I dumped it into a canvas element. So here I have a function called take photo. You size the canvas to be the actual height of the video so that it's a one-to-one copy. And then you simply just call context.draw image. You pass it your video tag, and then it's smart enough to just take a frame out of the video tag, which is pretty neat. And then you can convert that to a data URI and then make it downloadable by just putting a download attribute on a link, which is pretty cool. Or on iOS, you can long tap it and it'll allow you to save that to your actual photos. Next one, I think this is the last one, is resize observer. And this is essentially per element resize events, which I'm pretty excited about. So here's the very basic demo that I can possibly get. I have a div, and I just put a resize handle on it with some CSS, but this could be any element that you could possibly want, like a text area or a sidebar. And when an element gets resized, whether it's through my actual action of me drag and dropping it, or something on the page changing where an element gets bigger or smaller or taller or shorter, then it will fire this event, much like the last observer we looked at, and it will give us information about the X and the Y, the width and the height, the top, right, bottom, left, all the information about how big is the element and where is it on the page. So this is great because previously, what did we have to do? We'd have to listen for the only resize event that we had previously was the window resize event. And we had to listen for someone to resize the window and then check all of our other elements to see if they had resized themselves. And then still, there's some stuff I'm going to show you that it totally opened up different possibilities. So in this case, what we do is you create a new observer down in the middle here, new resize observer. You give it a callback. In this case, what I'm doing is I'm just taking each of the first entry, the first thing that triggered a resize element, and I'm just putting the actual the stats that it gives me directly right into the element. But down here at the bottom, that's the important part here, where we select the element that we want to watch, and then we want to observe, and then we simply observer.observe, just like we did with the ones where the pigs scrolled in. In this case, we simply just watch that specific element. And this is great because, like, who knows better how big an element is on the page than the actual browser, right? Because they have to paint them to the screen, so they have some lower level knowledge about how big these elements are, and it's much more performant for them to let us know when something has been resized. And I'm really excited about this because this is sort of a gateway drug to element queries. And if you haven't heard of element queries before, it's sort of like media queries, except media queries are all based on what? They're all based on the viewport width. But there's no way for us to currently make a media query for when something is a specific size. And we're in this age of component-based design, and often components need to go in different spots on our app. And they could be the full width or just a little bit smaller, or they could be in all different sizes that are sort of just spreading to how much width or height they have. And there's no way for us to currently target that other than using JavaScript, which there's some libraries out there, and you can do it in React and Vue and whatnot. But it's all going to be powered by something like this, where we take, let's kind of read this backwards. We're going to grab a list of videos __ list. We're going to watch it. And then when that thing changes size, then we're going to run this callback. And then we can check if that thing is greater than 400, greater than 300, or otherwise it's going to be small. And then we simply just apply a class of small, medium, or large to it. And this is a very simple example, but it looks a little bit something like this, where this is my app. I got a video on the left, and then I have a list of videos on the right. And my viewport is not changing at all during this. The only thing that is changing is the width of the videos. And as those videos get bigger or smaller, we're applying and unapplying small, medium, large classes to it. And then at that point, it's just a CSS problem. And we can apply transitions and font sizes and colors and whatever it is that we would like to do at that point. So, wow, that is some cool stuff. There's just a whole lot coming to JavaScript. The browsers are constantly evolving. Probably the question I always get is like, cool, but I have to support IE3. So, smart ass, what do you have to say about that? Let's go through it. So first, if you're using Async 08, you can use that immediately because promises are totally polyfillable, and Async 08 is syntax, so you can't polyfill syntax. You have to transpile it, and that's how you use Babel or Babel. If you're a weird person, you say it like that. Resize Observer is polyfillable, but it's expensive, so there is a polyfill out there that sort of falls back to the window on resize. So don't just go willy-nilly using it wherever you want. Think about it because it might cause performance implications. Intersection Observer has an official polyfill, so you can go ahead and check that out. And the Web Payments API is easily polyfillable, or it just falls back to a checkout form. So if you're on a browser that doesn't have this payment request API, then just fall back to a regular, insert your name, last name, credit card number, all that information that you're used to showing. Get User Immediate is everywhere. It's been around for like 7 years now, and it's finally in iOS Safari, so we can start using it in our applications to even just take a photo of the person and then upload it to their account. It's going to be really easy to do something like that. And I've built all kinds of stuff with it. Obviously, I told you about the like glasses, but I've also built like a bunch of filters. You can do green screen with it because all green screen is just if there's green behind you, you can take a frame of that video, dump it into a canvas, and then with Canvas, you get access to the raw pixel data, the red, the green, the blue values of each and every pixel. And you can simply just say, like, if this pixel is greenish, if it's in like a range of green, then take it out or make it transparent. And then that's how green screen works. And then you can just show whatever it is that comes from behind you. I've also done a security camera with it where you take a picture and you take a picture a little bit later, and you can compare those two pictures and see what percentage difference they are, which is pretty neat. And then you can, if there's like a 20% difference, that will trigger motion. And then I send a picture to over a WebSocket. There's all kinds of fun stuff that you can do with Get User Media. I think it's one of those things that if you're feeling a little bit burnt out on JavaScript, go check out Get User Media because it's so much fun to play with. So that's it. That's my talk. Hopefully you picked up a nugget or two of something fun. We got a little bit of time now, so I'm happy to answer any questions that you have. Oh, and I'm at Wes Bos on Twitter. I'm at Wes Bos on Instagram, which I'm trying to get past that 10,000 follows so I can you can allow links. Apparently you're not allowed links before that, so make sure you follow me on that and tweet me any questions you have. Speaking of green screens,
I know I changed it up. I went back to nothing too crazy for now, but I might keep switching it up on people. Everybody's got to pay attention out there. You never know what's going to happen. So, I mean, lots of excitement, first of all, over this font and presentation styling. So excellent job there.
Oh, good. Thank you. Can I tell you about the font a second?
Yes. People want to know about the font desperately. So tell us.
Okay. Can you still see my screen?
Yep.
Okay. This font was what is it called? Called Pure. And it's an SVG font, which I think that they're scrapping because every letter in the font is actually just a raster image, which I don't understand why it's an SVG because it's not vector at all. So every single letter is a raster-based image, and the font itself is like 40 megs or something like that because every letter is a photo. But it's amazing because fonts right now don't have the ability to have texture. Only raster-based stuff can really have texture. So I got it, and I was super excited about it. But the only browser that supports it right now is Firefox. And then also the font, you see me hovering right now, the font is black, but I wanted it to be white. But you can't color it because it's raster. Right. So I had to use a filter right here. Filter invert 100%. I don't know if you can see that or not. And then, so that was the only way to make it. There we go. See, it's regular black, but I wanted it to be white. So I just put an invert filter on the actual font.
You suffer for your fonts.
Yeah, it was a lot of work. And I got a lot of hate from people being like, you can't have a 40 meg font, but I can do it for a slide deck if I want because it's local, right?
I mean, this is what's wrong with the internet now. Why can't you have a 40 meg font? Whatever, your page loads slow. That's okay. Website, you do whatever you want. Unless somebody has a 40 meg data plan and they just ruin their month. Yeah, I think that most browsers now would block it because it's too big. I think Chrome blocks it, which is fine because I don't need it on Chrome. It doesn't work on Chrome. Right. Well, it's a big, huge hit. So I hope it's one you acquired somewhere. I take it. It's not like
yeah. I bought it on like Creative Market for $20 or something like that.
Awesome. Well, that was a huge thing. So nice job. There's even a better story behind it than I expected. So
yeah,
all the better. All right, we got a couple questions here. So one is just a few people would definitely want to see that error handling video. So I don't know if you want to. Whatever, you can post it up in the chat, whatever, but make sure you...
To YouTube and search Wes Bos Async. It's the first one. I'll post a link on... I'll post a link up on wherever the question is. Is there a question?
There is a question.
Here we go. I will do that right now.
Another question here was the difference between const and let. And sort of is what you're doing best practice or personal preference?
It's personal preference, widely regarded by many as best practice. So the idea behind let and const is let and const both cannot be made more than once. So if you create a let or a const variable like age, you can never create another variable in that scope. That's unlike var, where you could just create as many as you wanted. Okay. And so that's let and const. And the difference between let and const is that let can be reassigned, meaning that let age equals 20. And then if you want to make it 21, you just say age equals 21 or age plus plus.
Right.
Const is, it's not immutable because it just cannot be redefined or rebound. And what that means is that if, first of all, if you say const age equals 100, you can never change the value of that. Const name equals Wes, you can never change the value of that. However, if you have an object or an array, you can still modify the properties on that object or modify the items in that array. So if that's what you're looking for, immutability, then you need object.freeze. And that will freeze the entire thing, and you can never touch anything inside of it. But the whole idea behind const is not so much immutability, but making sure that you don't accidentally change what the value is. Whether if it's a number or a string or a Boolean, you can't change that value directly. But like if I created a person called Wes, I'm making sure that I'm not accidentally going to overwrite that with another Wes at some point, or I'm not going to accidentally overwrite it with another person, because that's always going to be Wes. Things about me can change. My age can change. My hair color can change. But the bound to that object of Wes can never change.
Well, that's a very good explanation. Thank you. One question, just I guess this is like very fundamental. I don't know the answer. Was just nailing down the synchronous versus asynchronousness of JavaScript, and there was some controversy about like its single-threadedness and so on and so forth. So, is it asynchronous or synchronous, or it depends?
Yeah, it's very confusing to me because you think about synchronized swimming. Right. And they all swim at the same time. And that doesn't make any sense because in JavaScript, synchronous means like you wait for one thing to be, there's a good Stack Overflow that goes on it. So first of all, JavaScript is single threaded. There's no concept of threads. JavaScript also does not run in parallel, which some people think that. Remember I showed you those two requests that went off? Right. It's concurrent. So instead of them both going like this at the same time, it sort of just goes back and forth to each of one of them. And whenever there's work that's needed on one of them, it will do it. So they're never actually running exactly at the same time, but whenever the data maybe comes back, the requests can happen at the same time. But when the data comes back, whichever one comes back first will get dealt with, and then the next one will get dealt with. So there are lots of things in JavaScript that are synchronous, like document.write or writing text to the actual screen. Like one example I have is try to put like 40,000 emojis in an H1 tag. That will lock up your browser. I've done it. And so that stuff is synchronous where you need to do it. But a lot of the heavy duty stuff is all asynchronous. And that is the reason why Node.js is Node.js and not Node another language, because Ryan Dahl, the guy who created Node, he was looking at languages and he's like, I need to create a better backend language, but it needs to be very asynchronous. And JavaScript was a perfect fit for that.
This is a history lesson here.
Yeah, if you want kind of a cool little history lesson, go on YouTube and look for like the first JSConf talk where Ryan Dahl introduced the idea behind what Node.js was. And it's really cool to see him introduce something and then just to look at, wow, this thing has become so massive now.
Yeah, that's funny how those. I have a similar story where I happened to be at this. I can't remember the guy's name now. This is so bad. But the guy who invented John Resig. I happened to be at the talk where John Resig announced jQuery, and it was like to like 20 people at this, whatever, this meetup in New York City, and then it's like. Now it's jQuery, and then now that was so long ago now that it's like there's 4,000 things since that, and it's funny how fast the internet moves.
It's crazy. I was at the conference when React was announced, and I was like being a snarky little asshole and tweeting like, "You don't put your templates inside with your logic. You have separations of concern." And I was tweeting all these things. And here I am, a huge React user. So obviously there was much smarter people than I figuring those things out.
So that kind of leads into the final question I had queued up. I don't know if you have a lot of Vue experience, but obviously the question that of course must be asked is React or Vue. Do you have a preference?
Yeah.
In the
So
Laravel ecosystem, Vue is very huge, but be interested to get your take.
yeah, I think so. I am primarily React. I've done very little Vue, like just a couple little things here and there. So I don't really have a good take on it. But from what I've seen, it seems like it makes a lot of sense. It seems like it's really good because like I'm the first person to tell you that React has a lot of funky things in it. Like the this dot whatever equals this dot whatever dot bind this, and there's all these funky things that happen in React, and once you learn them, you're like, all right, fine, I can work with these oddities. But Vue seems to just be. It reminds me of like the initial Angular, where it's just like, oh, this just works and it's awesome, and it doesn't make me have to figure out all these little edge cases and whatnot. So I'm pretty excited about it. So I have a podcast, Syntax FM, and Scott, who's my co-host, also is a React developer. And so what we're going to do is we're going to each build a little app in Vue and then talk about it on the podcast as to like what are our initial impressions coming from a React developer. So that's going to be, I'm pretty excited about that.
Yeah, that's actually going to be really cool. So everybody should definitely check that out because that sounds really, really interesting. That's a great idea just for podcast fodder. I have a podcast too. I need to come up with stuff like that. That's a good idea.
Tasty treats.
Got to find the topics. All right. Thank you very much. Great talk.
You're welcome. Thanks for having me.